So today we'll start with conservation of momentum. In conservation of momentum, first thing is center of mass. So in center of mass, first why do we need this concept? Till now we were dealing in terms of particles, but in real life we experience the extended body or continuous body which has different shape and size. So they deal there to apply this physics law like second law of motion, projectile motion equation. We need a point about which uh, if you apply these laws, all the laws will be valid. So center of mass is the point in extended body which motion would be identical to motion of a particle under the external force. Like when you apply a particle, any force. So whatever kind of motion it is having, same motion in extended body, center of mass would be. So we can write the center of mass. It is a point within the body or outside of body, which motion is identical to the motion of a particle under external. This is the basic idea of center of mass. What I said again we revise it. It is a point within the body or outside the body. It's not necessary that center of mass should be within the body. It could be outside the body. Which motion would be identical to the motion of a particle under the external. Under the external force, the way particle has behaved. We have found the acceleration of the particle. We have found the displacement. We have found velocity. So the way particle has behaved, same way the center of mass of the extended body will behave. So first thing, how to find the center of mass? Suppose first we'll understand it. Center of mass for discrete particles. Discrete particles, if many number of particles are there, in that case, how will you figure out the center of mass? So discrete system. So what do you mean by this discrete system? Suppose I take coordinate system, Cartesian coordinate system. I say m1 mass is present at point which coordinate is x1, y1, z1. One more mass is there m2. It is present at the coordinate x2, y2, z2. One more mass is there m3. Coordinate is x3, y3, and z3. Like way n masses are there in a space, we need to find the center of mass of this. So we define mathematically center of mass of these things. For x coordinate of center of mass, if I want to write m1 x1 plus m2 x2, mn x divided by m1 plus m2 plus m. If I want to define y center of mass, this will be given as m1 y1, m2 y2, mn yn divided by m1 plus m2. If I want to divide z center of mass, I'll write m1 z1, m2 z2, mn zn by m1 plus m2 plus mn. So this is how we can calculate if discrete system of particles are there. Means many number of particles are there. location. In that case, what would be the center of mass of that system? I'll take one example. Suppose we have given this is x axis, this is y axis. Mass 2 kg is at a coordinate of 2, 0, 2, 6, minus. Mass 3 kg is at the coordinate of 4, 4, and 3. Mass 4 kg coordinate is 3, 2, and 5. We need to find what will be the center of mass of this. So here I can write x center of mass will be given as 2 into x coordinate of first one. Second one mass 3, x coordinate of that one. Third one mass 4, x coordinate is 3, divided by 2 plus 3. So this will become 4 plus 12, 16, and again 12. So how much this will become? 28. Divided by how much? If I want to write y center of mass, this will be equals to how much? 2 into 6, 3 into 4, plus 4 into 2, mass that will come. So how much this will come? 12 plus 12, 24, and 8, 32 by 9. If I want to write the z center of mass, z center of mass, 2 into minus 1 plus 3 into plus 4 into 5 divided by. So minus 2 and 9, 7, 7 and 20, 27 by 9. So this will be the center of mass, x coordinate, y coordinate, and z coordinate. I'll repeat what I've done. As per this formula, we have x center of mass m1 x1 plus m2 x2 plus m3 mn m1 plus m2 plus m. So that's why so I use that formula. I put m value to x coordinate, m value, m2 value, m3 value, and divided by m1 plus m2 plus m. Same way, m1 y1, m2 y2, m3 y3 divided by m1 plus m2 plus m3. Same thing. We'll take one more question to understand this better. Suppose we have given a triangle is there. In this triangle, at this point I take origin, and this is the equilateral triangle. 6 meter, 6 meter, and 6 meter. Here 2 kg mass is there. Here 4 kg mass is there, and here 6 kg mass is there. We have to calculate what will be the x coordinate and y coordinate of the center of mass. So it is in planes. We are finding only x coordinate and y coordinate. Now, to find the center of mass, what do we need? We need to find what will be the x coordinate and the y coordinate for all the masses. So for 2 kg we have given this will be 0, 0. 4 kg what I can write? This will be 0. For 6 kg what we can write? 6 kg would be, I can say this angle will be 30 degree. So I can say this point coordinate would be 6 cos 30 and 6 sin 30. This will be how much? 6. So I have written in reverse way. It would be 6 sin 30 and 6 cos 30. If I know the x and y coordinate, I can write x center of mass would be how much? 2 into 0 plus 4 into 6 plus 6 into 6 9 divided by 2 plus 4 plus 6. So 24 and this will be how much? 18. So 32, 42 divided by 12. So what I can write? 14 divided by 4, 7 by 2, 7 by 2 meter. If I want to write the y center of mass will be how much? Y center of mass I can write m1 directly we can put the value. M1 is how much? 2 into 0. M2 is how much? 4 into 0. M3 will be how much? 6 into 6 cos 30. 6 root 3 by 2 divided by. Here I have cancelled sin 30 value is 1 by 2. This will become how much? 12. So this is 3. This will become how much? 4. So we are getting here 3 root 3. So this is how we use this formula. Center of mass. Any system, if discrete particles are given, means what different particles are there at a different point in the space. So how do we calculate the center of mass? We can use each formula. And I have explained these formulas with this example, where in this case I have taken three examples, there is space, there coordinate is given. Here I have explained, I have taken on an equilateral triangle, three masses were kept on the vertices. In that case, what will be the center? We'll take one more example. See, we have given uh, a 1 kg mass is there, it is kept at 3 kg mass is kept at they're asking this position vector. They're asking what is the position vector of the center. One way is that I can directly write in terms of position vector. One is that we find separately x coordinate, y coordinate, and z coordinate, and then write the position vector. So if I want to write directly, what I'll write position vector for the center of mass in terms of vector quantity. I can write as m1r1 plus m2r2 to what mnr divided by m1 plus m2. If I want to write in terms of vector, you can remember this as a separate formula. Anywhere you need to find out x center of mass in terms of. So let's use this formula. So here two particles are there. So I can write R center of mass will be 1 kg into what is the position vector? 2i plus 5j plus 13k plus 3 into 10i minus j plus 3k divided by m1 plus m2. So this will become how much? So this will be how much? 32i plus how much? Minus 3j plus 5j. 2j. This will be how much? 13. So 13 and this is how much? 9. 22k divided by. You can further simplify 16i plus j plus 11k divided by. This will be the position vector of the center of mass. So when you have problem like this, where you have instead of coordinate, you have given a vector, position vector. So in that case, to calculate center of mass, sometimes what happens instead of this combinations, means what discrete particles, we can have two combination of two system of two discrete particles. Like I can say two extended bodies are there. What will be the center of mass in that case? Suppose if we have given center of mass, we need to find combination of system of particles. If we have to write, means basically we have given there is a one place M1, M2, M3, M4, Mn masses. At one place, different group of masses M1 prime, M2 prime, M3 prime, and these masses are there, and their coordinate is respectively x1, y1, z1. Same way x2, y2, z2. And for these coordinates are x1 prime, y1 prime, and z1. If we go put to our initial relation that we have written here, can I write this relation in this manner? This will be equal to sigma mi. Same way this I can write mi yi mi. Same way this I can write mi zi mi zi mi. So if I use those relations, what I can write here, I want to find the center of mass for these two combinations. So basically I can write sigma mi equals to 1 m plus sigma m prime xi prime I is equals to 1 into, and simply this will become how much sum of mi plus mi. So if you see this relation, again I will go to the initial relation. From here, what I can write is basically I got center of mass. So if we copy this relation and write it here, so what I can write from here, sigma mi xi will be equal to m. Suppose this mass I am writing as m1 into x center of mass. If I am writing it. Same way I can write mi yi will be equal to m m1 m1 y1. Same way I can write mi zi. This will become m1 z1. X center of mass will be equal to how much? M1 x. For the other one, I can write m prime and something divided by m1. Same way, y center of mass, what I can write m1 y plus m prime y prime by m plus m prime. Same way, z center of mass, I can write it m1 z1 plus m prime z prime divided by m plus m prime. So this is basically will be the center of mass. Uh, two system, two system of particles are there. I'll explain this thing by this question. you will get better idea. Suppose two rods are there. And we need to calculate the center of mass of the system. So when you need to calculate the center of mass, position of center of mass, position you can calculate only when there is origin. Suppose we have given this point, about this point, center of mass. Suppose both the rod have length L and mass is also same. So this problem I can simplify in this manner. At the origin, one mass is there, because as per this, I can simplify this combination of mass as a single mass at its center of mass. So same way, this rod, I can replace this rod by a single mass at its center of mass m0, 0. Same way, the other one also can be fixed at the center of this one, this m. And what will be the coordinate of this one? 0 by 2. So if I want to write the center of mass, only x center of mass will remain 0, 1. X center of mass will get 0. Y center of mass will become how much? M into 0. M into L by 2 divided by m plus n. So this will become L by 4. Same problem is simplified by using the last one. We'll take one more problem. Suppose we have given two rods are there, but they have arranged in some different manner. We need to calculate center of mass with respect to the, again we need a point. Suppose about this point, they're asking you to calculate the center of mass. Very good. So again, the first rod, suppose both are having same mass and length ml. This will also so this one coordinate what I can write? This one coordinate I can write L by 2 and 0. This one coordinate I can write as how much? 0 L by 2. Now if I want to write the center of mass of these two, what I can write? X center of mass. Okay, I can take here y coordinate. If I take this as x and this as a y axis, then you need to write this coordinate as negative. Similar thing we could have done, but here only y axis was involved, so I can take y axis in the downward direction. But if x and y axis both is involved, if x axis is in this direction, y axis is only in this direction. You have to write y coordinate here. X center of mass, if I want to write here, what I'll write? M into L by 2 plus M into 0 divided by M plus M. So this will become how much? ML by 2 by mm. This will become L by 2. If I want to write y center of mass, what I can do? I write M into 0 plus M into minus L divided by 2m. So this will I get as how much? Minus L by 2. Where will be the center of mass? Center of mass will be somewhere here. What is the coordinate we are getting? L by 4 and minus L by 2. Now see, in the first statement I have told, the center of mass, it is a point within the body or outside the body. Till now we were getting the center of mass in case of continuous body. You can see in this example, center of mass is outside the body. So this is how we have to use the concept of center of mass. Two set of system, more than one set of system. I'll take one more example. Suppose we have given there is a square, and there is a circular disc. The diameter and the square side both is same. This is also A, and this is also diameter is radius is A. You need to figure out where will the center of mass, x component of the center of mass. Why I know it will be here. Why I'm saying that why center of mass is there? Because both are having the same point. Now x center of mass if I need to find where it would be. So again these two problem I can replace as a 2 point mass problem. First I'll find out the center. Remember that if body is uniform, and symmetrical, this geometric center and the center of mass both would be at the same point. So this coordinate I can write as this will be how much? A by 2 and A by 2. This coordinate will be how much? 3A by 2. I'm writing this as a. If I want to find the center of mass, x center of mass first I write. So again, now here one thing is there whether they have given that their density is same. They are made from the same material. Both the things are made from the same material. Then what we need to do? Because here mass they have not given same. So I'll write x center of mass m1 x1 plus m2 x2 by m1 plus m2. Again for mass we need volume. Given that it's a two-dimensional object, both are having same thing. Both are having same thing, and that is given as. So what I can write that means we can after this we can use it as a formula. Column. M1 I can write as density of first one, area of first one into thickness into x1. M2 I can write density A2 thickness into x2 divided by density into area into thickness density into area. So if we simplify this, we will get here center of mass formula. Two objects are having same density. So this I can write at in terms of area a1 x1 plus a2 x2 by a1 plus a2. Same way y center of mass we can write as a1 y1 plus a2 y2 by a1 plus a2. And z center of mass we can write as a1 z1 plus a2 z2 by a1 plus a2. Right? Now let's try to use this concept and use this concept and solve. Remember that whenever you have to write in terms of area, you can do these relations. So this is x coordinate, y coordinate, and z coordinate. So if I use this to solve this problem, what I can write x center of mass. A1, first one area will become how much? A square. What is the coordinate? X coordinate a by 2. Second one area how much? Pi a square by 4 into what will become its coordinate? 3a by 2 a1 plus a square plus pi a square by 2. A square we can cancel out. So this will become how much? A by 2 plus 3a by 8 This will become how much? 4 plus 5 by 4. So this I can do what? I can multiply 4 and 4. So 7a by 8 divided by 4 plus 5 by 4. So 7a divided by 2 into 5 plus 2. This will be the x center of mass. If we calculate y center of mass, so what it will become? A1 into a by 2. A2 into a by 2. Both are same. A1 plus A2. So basically we will get as here a by 2. That's what I was telling. Y center of mass. Because both center of mass is same. So this is how we are supposed to use this formula when we are given area in terms of area, how to calculate the center. Again, I will repeat this thing. For x center of mass, a1 x1 plus a2 x2 plus divided by a1 plus a2. Y center of mass, z center of mass, a1 z1 plus a2 z2 by a1. Let's take one more problem based on this concept. Suppose we take this problem. We have given there are 7 homogeneous bricks, each of length L, are arranged as shown in figure. Each brick displaced with respect to one in contact by L by 10. They're asking find the x coordinate of the center of mass relative to the origin. It's a very nice problem. Let's try to understand it. What I can write the coordinate of first one L by 2. I need only x coordinates. This one x coordinate will be how much? L by 2, and it is displaced by L by 10. This one will be x coordinate L by 2 plus 2 L by 10. This one x coordinate will be how much? L by 2 plus 3 L by 10. This one x coordinate will be how much? L by 2 plus 2 L by 10 because it has moved in backward direction. This will be how much? L by 2 plus L by 10. And this will become how much? So if I want to write, I have written only the x coordinate. X center of mass. They're asking x coordinate of the center of mass. So what? M1 x1 plus M2 x2. How many 7 are there? M7 x7 divided by M1 plus M2 to what? M7. Now see, first one all are identical. M first one coordinate is L by 2. M second one coordinate is L by 2 plus L by 10. Third coordinate is M into L by 2 plus 2 L by 10. This one I can write as M into L by 2 plus 3 L by 10 plus M into L by 2 plus 2 L by 10 plus M into L by 2 plus L by 10 plus M into L by 2. This divided by how many? 7. 7 masses are there. So let's simplify this. M So 7L by 2 plus 2L by 10 to 12 by 10 and 1 3L by 10 divided by how much? I can multiply here with the 5. So this will come 35 plus 2, 37 plus 4, 41, 41. So 44L by how much this will come? 70. So 22L by 35. Basically, this problem is similar thing that we have learned. Combination of several masses are there. Then what we do, we replace those masses with their center of mass, and we write their center of mass coordinate. And at the last, what we are doing, we are writing the formula instead of means what we are doing, we are writing the coordinate of these bodies m1 x1 m2 x2 m3 x3 until seven masses are there. So we have written all the seven terms. Let's take one more problem based on this concept. We have already. Now let's understand. Till now we have understood how to find the center of mass. What will be the point? Center of mass. How to calculate the center of mass position in the body. So these were the bodies which were discrete system of particles. What about the center of mass when the continuous body is there, extended body? Center of mass for extended body. Suppose we have given a extended body has certain. So what we have to do, we have to take a small element in the body. Basically, this extended body is what infinite number of particles are there, and if number the terms becomes infinity, what we have to do? We have to do the integration. Integration is basically the sum of large number of small quantities. If we define in one way. So here, if I want to write the center of mass, if I want to write the exponent of the center, so this will be given as x into d. And this dm mass, the small element coordinate will be what? This dm mass x into dm will integrate it and will divide by dm. Same thing as the initial formulas. Just here the number of terms. If number of terms is very large, the same formula will turn into the integration. Here, if I want to define the y center of mass, what I will write here? Y center of mass. Y into dm. If I want to write the z center of mass, this will be what? Z into dm. This is how they be defined. Center of mass. Extended body. We'll take few examples. First, we'll define what these things are. The terms we have. dm is mass of the small element. X is what? X coordinate of the small element. Same y is what? Y coordinate of small element. Z is what? Z coordinate of small element. So this is what basically x center of mass, y center of mass. We'll take an example. After that, it will be easier for you to understand. Suppose there is a rod. Mass is m and length is L. We need to calculate the center. We know that it will be at the center since it is a uniform rod. But if you have to prove it, we use that formula because it's extended body. So what we have to do, we have to take a small element. So small element should be in identical to the actual element. So this is basically a rod is made of infinite number of particles. So here I am taking a small element as a particle. So this is x. So this section length will be how much? Dx. So if you want to find the x center of mass, we can find only one point because one dimensional body. So what we can write here x center of mass as per our formula. X into dm and integration of dm. How to calculate dm? We have given here the mass is uniformly distributed. So what I can write then? If L length have mass m, so unit length would have mass how much? M by L. Then dx length would have mass how much? M by L to dx. Basically, we can say our dm will be m by L to dx. L length have mass m. So unit length would have mass how much? M by L. So dx length would have mass m by L into dx. So our dx length is our dm, small element. So small element mass is how much? M by L into dx. So let's put this value. So what it will become? M by L into x into dx. This will become m by L into dx. M by L and m by L. X integration will become how much? X square by 2. From where to where? 0 to L. Dx integration will become x from where to where? 0 to L. So this will become L square by 2 by L. Center of mass we are getting. So this is how we calculate, use the formula, the integration center of mass for extended body. If you say if the rod were not uniform, what will you do? Can't we use this formula? Let's see. What will happen if the rod is not uniform? Suppose a non-uniform rod is there, and if rod is non-uniform, we have to provide density. They will be given in that will be given in the question. So suppose we have given this is equals to 4 plus 2x, and the length of the rod we have given as L is equal to 2 meters. We have to calculate what will be the center of mass from the end. This end is B. Again, I'll explain the problem. Problem is what? There is a non-uniform rod. Non-uniform height is non-uniform because density is not uniform. As we are moving from the end A, the density is increasing. So it is a non-uniform rod. In this case, how will you calculate the center of mass? So what we can write? X center of mass is equals to lambda x into dm by integration of dm. So we have given what we can write dm here. Density we know. We will take a small element at a distance x. So dm will become how much? Lambda into dm. So lambda into dx into x integration of what? Dm. I can write lambda into. Now here, if lambda were constant, we can cancel out. But lambda here is not a constant. So 4 plus 2x into x into dx. This will become 4 plus 2x into dx. Let's integrate it. So 4x dx, this will come 2x square dx. This will be 4 dx plus 2 into dx. From where to where it's varying? It's varying from 0 to 0 to 2, 0 to 2, and 0 to 2. So what will become the integration? 4x square by 2. This will come to x cube by 3. From where to where? 0 to 2. This will come how much? 4x, 0 to 2, and this 2, x square by 2. Done. This will come. So what we can write this? We can write this as 2 into 4 minus 0, 2 by 3 into 8 minus 0, 4 into 2 minus 0, plus this will come how much? 2 square minus 0. So this will come how much? 2 into 4, 8, plus 16 by 3, 8 plus 4. So 24 plus 16, what? 30, 40 by 3. 40 by 3 and divided by 12. So this will come how much? 10, and this is 3. 10 by 9. I hope it was not that much complicated. Try to understand what we did. We have tried to find the center of mass for a non-uniform rod. So here we had given density. We have calculated x center of mass by using the relation x center of mass is x dm by dm. How we can calculate the dm? Dm will be equals to density into the length of the segment. What we have done, we have taken a small element which length is dx. So mass of that small element will be what? Density at that point. We have taken the small element at a distance x. So lambda into dx, we have put in the equation. And after that, we have simplified. There is one more basic type of problem we have given. Suppose we need to calculate the center of mass for a circular arc. So suppose this circular arc have radius r and it is making an angle theta here at the point. We need to calculate the center of mass. So here we can divide it into two segments. This will be x-axis and this will be the y-axis. If we see the here we have assumed that both the sides angle is same theta by 2 and theta by 2. So if it is symmetrical about this y-axis, so I can say here x center of mass will be 0 because this part and this part. If I want to find the center of mass y coordinate, mathematically we can find the x coordinate also. So what I did, I took a small element small element, very small element. So this is a small element. Suppose this one is making angle alpha here. I'll do one thing. I'll put this center of mass. So this mass is how much? This mass I can take. You would have learned in trigonometry that if a circular arc forms an angle theta here, this arc length is L, this is R. So theta we define L by R. So this part length, this dx, will be given by how much? From here L I can write as R theta. So length of this is small. I can write as how much? R into d theta. Because the small segment, not d theta, we have taken the variable as alpha. So this will come how much? D alpha. The small segment, how much angle it is. This we have taken as. So if I write the x center of mass, what is the formula? X dm by integration of d. So x coordinate will become how much? Radius is r, so I can write the x coordinate will be r sin alpha, r sin alpha. And dm what I can write again? It is linearly, mass is uniformly distributed. And I'm assuming that is a linear mass density is lambda. Means mass could be m. So linear mass density I can write it as m by. So dm I can write as lambda into dx. This will become how much? Lambda into r into d alpha. Here radius is. So dm I can write lambda r into d alpha. Remember this is a uniform rod, so lambda will be dm I can write lambda r into d alpha. This is r. So lambda lambda r. So r sin alpha d alpha. So r integration of sin alpha is what? Minus cos alpha. And see alpha is changing from where to where? Minus theta by 2 plus theta by 2. Divided by theta by 2 minus minus theta by 2. So this will become how much? R cos theta by 2 minus cos theta by theta. So this will become 0. That's what I told you in the starting. The center of mass will become 0 because of the symmetry. If I want to find the y center of mass, what I can do? Y dm by dm. Everything would be same, only this integration part instead of sin alpha, it will come as cos alpha into d alpha by integration of d alpha. Or this will come how much? Cos alpha integration sin alpha, and from where to where? Minus theta by 2 divided by how much? So r this I can write as 2 sin theta by theta. So y center of mass we got as, in case of circular arc, symmetrical above the normally x center of mass. This just I explain how to calculate. So why did I explain this? Mostly they ask this question, the center of mass of semicircle, and it will help you this derivation in further also many places you will get the question regarding that calculate the gravitational field, calculate gravitational field, electric field. So where this analysis will help you to understand how to take a small element in the case of circular arc. This analysis will help you in many problems. That's why I've taken this question, this derivation part. In case of circular arc, a semicircular arc, semicircular, what will become the theta value? Theta value will become pi. If theta value is pi, x center of mass is already 0. Y center of mass will become how much? 2r sine pi by 2 by theta is how much? Pi. 2r by pi. This will become the center of mass. So this is how we'll deal the problem related to the center of mass for extended body. I have taken two cases here. One case I have taken for the rod, that rod informed rod and non-informed rod was there. Second case I have taken for the circular arc, how to calculate the center of mass. So now we have concluded the part how to calculate the center of mass, whether it's a discrete system of particles or whether it's a extended body. So one center of mass we have discussed how to find in a body. Now we'll understand how the motion of center of mass will happen. So now we are starting motion of center of mass. Already we know position of center of mass. What we write? M1 R1 plus M2 R2 plus Mn Rn by M1 plus M2 to what? Mn. If I differentiate it, what I'll write velocity of M1 V1 plus M2 V2 to what? Mn V1 by M1 plus M2 to what? Mn. Just differentiate both sides. This is velocity of center of mass, position of center of mass. If I want to write acceleration of center of mass, again differentiate both sides. M1 A1 plus M2 A2 plus Mn A by M1 plus M2 to what? Similar thing. We already knew the formula for position of the center of mass. M1 R1, M2 R2 plus acceleration of the center of mass. If I write this relation again, what I can write? M1 plus M2 plus this. So mass of system into velocity. M1 V1 I can write momentum of first particle, momentum of the second particle. Till about momentum of the nth particle. So P1 plus P2 plus Pn, this represents the momentum of the system. So momentum of the system I can write mass into velocity of the center. Same way here, if I use this relation, what I can write? Mass into acceleration of the center. M1 A1 I can say force on one particle, force on second particle. Basically sum of all the forces. So basically I can write Fx will be equal to M into acceleration of the center of mass. So this is the analysis regarding the motion. We'll take few examples and then we'll understand this velocity of the center of mass. Suppose we have given a triangle is there. Before that, I will take one. So there is a mass m, 4 kg. It is moving with the velocity in the x direction with a speed of 8 meters. There is a mass 6 kg. It is moving along y direction with a speed of 3 meters per second. Calculate the velocity of the center. If you want to calculate the velocity of the velocity of center of mass, m1 v1 plus m2 v2 divided by m1 plus m2. So this I can write 4 into 8I because this first one is moving what direction? Direction. Second one is moving in y direction. 8 into 3j divided by 4 plus 8, so 12. So I can write this 8I plus 6j by 3. This will become the velocity of center. Simply, what we have to take? We have to take the velocity of velocity of second one, and then m1 plus. We'll take one more example. Suppose we have given there's a triangle here. One particle mass is 4 kg. So this one moving in this direction with a speed of 4 meter per second. There is a one particle here 6 kg. This one also moving in this direction with a velocity of 4 meter per second. There is a one particle here. This one also moves. This is 8 kg. And this one also moves with the same speed, 4 meter per second. They're asking calculate the velocity of velocity of the center. So before, since velocity are in different directions, so we have to define first. So I'll take this as x-axis and this will be our y-axis. So if I write, give it some name. Suppose this is particle 1, this is a particle 2, this is a particle 3. So if I write the velocity of 1, what is the question? Find velocity of this. So first thing here we have to find out velocity of each particle. So v1 I can write as how much? V1 I can write 4I. V2 will be how much? V2 I can write. No, this is the equilateral triangle. This angle will be how much? So minus 4 cos 60I plus 4 sin 60j. So minus 2I plus 2 root 3j. Velocity of third one will be what? We can say this angle will be 30 degrees. So this will become minus 4 sin 30 I plus 4 cos 30j. So this will become minus 2I plus this will also be minus. So minus 2 root 3j. So what I can write the velocity of center of mass. Velocity of center of mass m1 4 into 4 m2 6 into minus 2I plus 2 root 3j plus m3. M3 will be about 8 into minus 2I minus 2 root 3j divided by what? M1 plus M2 plus 4 plus 6 plus 8. So 16I minus 12I plus 12 root 3j minus 16I minus 16 root 3j by 18. So 12I and this 16I, 16I minus 12, 12 root 3 and minus 16 root 3. So this will become minus 4 root 3j by 18. So minus 6I minus 2 root 3j by 9. This will be the velocity. Again, try to understand this. Try to understand this. What I did, I found first if we are given velocity, particles are moving in different directions. So what you're supposed to do, first find the velocity of all the individual particles. Once I know the velocity, but since they are moving in different directions, we need to define first x. So I have defined the x-axis and y-axis. As per the axis, now I'm writing the velocity in the vector form. 4I minus 4 plus 60 minus 4 minus sin 30 minus 4 minus cos 30. And then I have calculated the velocity of the center. Now let's take one problem based on acceleration of the center. So acceleration of center. Suppose we have already discussed this. Suppose we have given a mass is there 6 kg, a mass is there 4 kg. On this mass at 12 Newton of force is acting. They're asking us to calculate what will be the acceleration of the center of mass. 4 kg there is no force acting. So here what we can say, acceleration for 6 kg equals to 2I. Acceleration for 4 kg 0. So acceleration of center of mass will become how much? 4 into 0 plus 6 into 2I by how much is it? 4 plus 6. So 1.2I meter per second. This is how we calculate the acceleration of the center of mass. Suppose if we take one more problem based on this. Let's understand this problem. This problem you would have seen the laws of motion. There we need to calculate the tension. Here we are trying to calculate the acceleration of the center of mass. So since these two masses are different, so heavier one will go down. Which one is heavier? Mass of these two. So this will go down with some acceleration, and this will go up with some acceleration. So until unless I know these values, I can't calculate the acceleration. And second thing here, sign convention matters. So this is x, and this is y. So if I take this value as positive, this value will be what? So what will be the acceleration? How will you calculate? B tension T in upward direction, B mass is G. If I am writing for B. If I am writing for A, tension in upward direction, in downward direction, 2G. So 2G minus T. So for this one, T minus G is equals to A. Equation 1. It is going up, so this force will be positive. It is going down, so 2G force will be positive. 2G minus T, 2A. This is equation 2. Add both of them. So we can write from 1 plus 2, what it will become? G is equals to 3A. So acceleration will become how much? G by 3. Now I know magnitude of acceleration. This question gives us here the magnitude of acceleration. So for B acceleration is positive, for A acceleration is what? Negative. Write the acceleration of center of mass. So A mass of A into acceleration of A, mass of B into acceleration of B divided by mass of A plus mass of B. Mass of A is how much? Mass of A is 2 kg. And what direction it is? Downward direction. So minus 1 into G by 3 MA plus this is 2 plus 1. So minus G by 3 by 3. So minus G by 9 meter per second square. So basically what we have to do, we have to find individually the acceleration of these particles, how they are, with what rate they are moving. And then we have to use the equation of acceleration of center of mass. 1 1 plus whatever is the number of terms that many terms we have to use. So this was the regarding the motion of the center. Now let's understand this equation. Now we're try to learn conservation of linear momentum. Basically, it's a very simple thing, but very useful. It's very simple to understand. It says that if external force on a system, if external force on a system is equals to zero, then linear momentum of the system will be very simple. It says that if force is not there, there is no external force. The linear momentum of the system, if external force on a system is equal to zero, then linear momentum of the system will be conserved. Conserve means what? In physics, if a conserved term is being used, it means the with respect to time, that physical quantity is going to remain unchanged. Saying conservation of linear momentum means for time duration means the time till the time the external force is not there, the momentum of the system will not change. What do you mean by here system? System means it could be one body, two body, three body. So whatever part you have considered as a system, in that part if force is not active, that combination of body, the linear momentum will be conserved. It may possible that individual body momentum may increase or decrease, but overall momentum of the system will remain. If you remember Newton's second law, what Newton's second law says that F external is equals to the rate of change of movement. So that's what this theorem says that if F external is equals to zero, then dp by dt will be zero. If dp by dt is zero, means what? T should be constant. T equals should be constant, so you can write as initial momentum should be equals to final momentum. And here is the relation how we define the momentum of the system. So Momentum of the system, how will write? Right in this, whatever the momentum of the individual particle is. So basically, conservation of momentum, linear momentum says that if external force on a system is equal to zero, linear momentum will be. What further we can deduce from this thing, this relation? If external force was not there, and initially if the velocity of center of mass was zero, if u center of mass is equals to zero, if system of if center of mass is moving with right in absence of external force, if center of mass is moving with some velocity, it will continue to move with same velocity. Otherwise, we can say if center of mass is at rest, it will remain at rest. This is the meaning of the statement. If there is no external force, center of mass, if it is moving some velocity, it will continue to move with the same velocity. Because we can say V system, I can write also M into V center of mass. V center of mass is not going to change. So velocity of center, if system mass is constant, so velocity of center of mass should remain constant. If center of mass is moving with the same velocity, if there is no external force, center of mass should continue to move with the same velocity. If center of mass is at rest, center of mass is at, it will remain at rest. So we can say delta x center of should be zero in the absence of any external force. Right. Delta x center of will be equals to zero in the absence of any external force. This is a very important result based on this many questions will be asked. So first we'll take question based on this delta x center of mass. Then we'll go to take the question based on conservation. It's a very basic problem we have. They have given two blocks of masses 10 kg and 20 kg placed on the x. First mass moved by a distance 2 centimeter. By what distance the second mass will move to see the position of center of mass. See what we write. We write x center of mass is equals to m1x1 plus m2x2 plus mnx by m1 plus m2 plus mn. So delta x center of mass I can write as m1 delta x1 plus m2 delta x2 to what mn delta x with this with the change in the center of mass. If I want to calculate now, get divided by m1 plus m2 plus. In the problem they have given the position of center of mass should remain unchanged. So delta x center of mass is how much? Here two particles are involved. m1 delta x1 plus m2 delta x2. This should be 0. m1 is how much? 10. The first one position has moved by a distance how much? 2 centimeters. m2 is how much? 20 kg. This is delta x. This should be 0. So delta x2 should be equals to how much? Minus 1. If three particles were there, what I would have written? I would have written m1 delta x1 plus m2 delta x2 plus m3 delta x. Let's take one more problem based on this. We have given Mr. Verma, Mr. Mathur are sitting at the two extremes of a 4-meter long boat, standing still in water to discuss a mechanics problem. They come to the middle of the boat. That become a problem because of movement, so that becomes a physics problem. How the center of mass moves. Neglecting the friction of water, how far the boat moves on the water during the process. Now, if we neglect the friction between the boat and the water, there is no external force in the system. It means the delta x of the center of mass should remain unchanged. So I can write here delta x of the center of mass should be 0. But to do the analysis, we have to draw the diagram. So how to approach this problem? Try to understand. Take initial position, take any one point at 0 as origin. So Mr. Verma and Mr. Mathur are sitting in the two extremes. So Mr. Verma is here. How much Mr. Verma weighs? 50 kg. Mr. Mathur is here. How much his weight? Weight is 60 kg. 4-meter long boat is there. So boat I can write at the center of mass somewhere. This one mass is 3 masses. Now, once they come here, so what will happen? The boat will displace. I'm assuming that it has moved in leftward direction. And assume it will move in rightward direction. So I assume the boat has moved in the rightward direction by a distance. Now where they are, they have come to the middle of the boat here. How much is the long boat? 2-meter long boat. So this distance will become how much? 2 minus 6. So what I can write here, delta x center of mass equals to m1 into delta x1 plus m2 into delta x2 plus m3 into delta x3. This should be equals to 0. So m1 is how much? 50. Delta when we write x final minus x. So this one I am taking as 1. This one I am taking as 2. This one I am taking as 3. Body 1, body 2, body 3. M1, what is the final position? 2 minus x. What is the initial position for M1? 0. M2, mass is 60 kg. What is the final position? 2 minus x. Whatever the initial position? Minus 2. M3, 40. Whatever distance any one point will move, same distance the center of mass would move. So both this is a fixed body. So 40 minus x. This should be equals to what? This one also, if you want, you can write in the similar fashion. Final position minus initial position. 40 into what is the final center of mass? Where is finally? 2 minus x. Where the center of mass was initially? So this I'll get as 100 minus 50x. This I'll get as minus 60x minus 120. This I'll get as minus 40x. This should be equals to, so this will come as 150x is equals to 20 minus 20. So x will become how much? Minus 20 by 150. So minus 2 by 50. If I've got minus sign, means what? Whatever I have got the value, it will reverse, means what? Both will move in this direction. I hope it was not that much complicated. What I have done, let's understand it again. Written delta x center of mass will be 0. Why delta x center of mass will be 0? There is no external force on the system. How many bodies are there? Three bodies are there. M1 delta x1 plus M2 delta x2 plus M3 delta x3. M1 50, 2 minus x. 60 into 2 minus x minus 4. How am I writing delta means? When I am writing delta x, final position minus initial position. So final position I have taken as 2 minus x. Initial position it was origin. Final position where the 60 kg, 2 minus x final, initially it was at 4. From here this length is 4 meters. This board initially center of mass is here, finally center of mass is here. So 2 minus x minus. So this is the one of the concept when there is no movement of the center of mass. Let's see the other aspect of the conservation of movement. We have seen this. If center of mass is at rest, it will remain at rest. Now let's understand this part. Momentum, initial momentum should be equal to final momentum. So I would like to take one more problem based on delta x center of mass. This is also a common problem. We can discuss this then we'll go for the conservation of momentum. So we have given this problem. A projectile is there. We have given this projectile is fired at speed of 100 meter per second. And what happened at the mid of flight, the maximum height, it broke into two parts. So they're asking us here if they broke into two parts, where these two parts will land. If one position is this, one position is that. This type of problem they ask. So basically, you understand how to approach this problem. So try to think. It has broken at the highest point. At the highest point, is there any external force in x direction? In y direction, we have gravity. But in x direction, is there any external force? If there is no external force, means what? The particle which it was supposed to uh, hit at the range, still the center of mass will hit at the range. Even though it has been converted into two parts, center of mass motion will remain same because there is no external force in this direction. It means it is the center of mass will hit at the same point. Might be these two individual particles will hit at the different location, but the center of mass is going to hit at the same. So now see we have given at the highest point, projectile is converted into masses of ratio 1:3. So one mass is 3m by 4, and one mass will become m by 4. The smaller one, this mass, comes to rest. They're asking find the distance from the launching point where the heavier piece will land. So what I can write, delta x center of delta x center of mass should go to the same position. M1 x1 plus M2 x2 by M1 plus M2. I'm taking m1 is equals to m by 4. What is the position for x1? Land here, r by 2. X1 is r by 2. X center of mass where should land? At the same range. So let's simplify this. R is equal to m by 4 into r by 2, 3m by 4 into x divided by what? M plus mm. So 3x2 by 4, this will come r minus r by 8. This will come 7r by 8. So this will be how much? 2. So I can write this as x2 will become 7r. And r we can use the formula. The range is given by how much? U squared sine 2 theta. So u we have how much? U we have 100. So 100 is squared. Here theta is 37 degrees. So I can write sine 2 theta as 2 sine theta into cos theta. G value is how much? So this will be 25. This will become how much? 400. 0 done. How much? 80 and 12. Where this x value is 960. So where the other part will lie? 7 by 6. 960. Simplify. So this was related to one of the. Here also we have used the concept, but the delta x center of mass should delta x center of mass should be 0. Means this particle should land at the same position. Means center of mass should land at the same position. If it is divided into two parts, we can use the concept of x center of mass m1 x plus m2 x. Let's take some problem based on the conservation of momentum. If I take see we have given this problem. In Indian buggy, used to in old age, a wooden plate is fixed on the rear on which one person can sit. This cart was moving with a speed mass is 200 kgs, moving with a speed of 10 kilometers per hour. As it overtakes a schoolboy walking at a speed of 4 kilometers per hour, the boy sits on the wooden plate. The mass of the boy is 25 kg. What will be the new velocity? Try to imagine this situation. There is a cart. I'm drawing it this way because I'm not that much good in drawing. Instead of looking like a buggy, it looks like something else. So drawing simple. So situation is this: this cart is moving with a speed of 10 kilometers per hour, and it has crossed a boy. This boy was moving at the speed of 4 kilometers. So if you think only about the cart will apply a force, then the boy will jump on. If we think about boy will apply some force on the cart because he has to climb on the cart. But if we think the situation between these two, if we take these two as a system, there is no external force on the system in horizontal direction. So we can conserve the momentum here in the horizontal direction. Again, try to understand. Boy is applying force on the cart. Cart may apply force on the boy. But if we take these two as a system, the net force on the system is zero. There is no external force. These two are applying force on each other, but there is no external force which is acting on these two in horizontal direction. So we can write initial momentum should be equals to final momentum as per the conservation of linear momentum. It says that if there is no external force on the system, linear momentum will be conserved. How many particles are there? Two particles are there. So what I'll write m1u1 plus m2u. This will be equal to m1v1 plus m2v2. So how much? 200 into 10 plus schoolboy mass is how much? 25 into 4 This will be equals to, now both are as a one system. They are on this. So this will become how much? 225 into V. So V I can write as 2000 plus 100. 2100 by 225. Simply we have to understand whether they are applying any force on each other. Let's take one more. Let's take this problem. We have given a ball of mass 0.5 kg moving at a speed of 5 meter per second collides with another ball of mass 1 kg. After the collision, ball stick together and remains motionless. What was the velocity of 1 kg? Velocity of 1 kg ball before the collision. See, even though this one is moving at what speed? 5 meter per second. This one velocity is unknown. And we have not given what direction. Now, after the collision, what is happening? After the collision, they will stick together and remains motionless. There is no motion. So velocity becomes zero. So what I can write again? These two are applying force on each other, but there is no external force on the system. So initial momentum should be equal to what? So 0.5 into 5 is the initial the momentum for first one. Other one velocity I don't know. 1 into v. These two after the collision comes to that, so v will become 0. So v I can write as minus 2.5. Means it should have been moving in opposite direction. See, after this conservation of momentum concept, we have a one concept pending that is called collision, and it is one of the important concepts. Based on this, they have asked many questions. So, what is collision? Collision is what basically is the redistribution of momentum of the system. So, mostly we understand when the two body collide, they should be in contact, but it's not necessary. The momentum can be shared, can be redistributed without making a contact. So, collision is a process in which momentum of the system is redistributed. Collision is a process in which momentum of the system is redistributed. So what we can convey it is not, we are not losing any momentum. Basically, we can say in collision the momentum will remain conserved. So there are different types of collision. If we consider, if we think them based on energy, we can divide the collision into two categories. One is called elastic collision, and one is called inelastic collision. So, what is elastic collision? In elastic collision, right? First, it is a collision, as we have said. It is a momentum will be redistributed. We can say in elastic collision, initial momentum of the system is equals to final momentum Second point, initial kinetic energy is equals to, better write other statement, not initial momentum, linear momentum is conserved, and initial kinetic energy is equals to final kinetic energy. In case of elastic collision, there is no loss of energy. Whatever the mechanical energy is there, that will remain conserved. For time being, the kinetic energy will be converted into potential energy. Again, at the end of collision, this potential energy will be given back to the system. But in case of inelastic collision, some part of mechanical energy are converted in the form of heat or some other non-usable form of energy. So there is some loss of energy happens. So that kind of collision is called inelastic collision. If there is no loss of mechanical energy happen, is there in the collision, then that kind of collision we'll call as elastic collision. Momentum will be conserved whether it's a collision is elastic collision or inelastic collision, but kinetic energy. Again, I have not used the term kinetic energy is conserved. I have used the term initial kinetic energy is equals to final kinetic energy. Kinetic energy will not be conserved. You can understand this concept of collision. Two masses are there, M1 and M2. And here, if you add a spring, what will happen? This is the situation before the collision. Before collision, this is V1, this is V2, and V1 is greater. During the collision, here if you say X, this is equals to M1, this is M2, and here is V1 prime, V2 prime. Here X will not be zero. Means what? There is some potential energy. So I'm just trying to explain how you can understand this elastic collision. No energy is being converted in the form of non-usable. After the collision, what will happen? This is M1, this is M2, this is the spring, this is V2 double prime, this is V1 double prime. You can say V2 double prime will be greater than V1 double prime. So this is basically happens in case of elastic collision. In the middle, some of the kinetic energy being converted into potential energy. That's why we don't say kinetic energy is conserved. What we say, the initial kinetic energy, because there is no loss of energy, initial kinetic energy will be equal to final kinetic energy. If I say inelastic collision, here some energy will be converted into heat or some another non-usable. So first statement, momentum will be. Second statement, initial kinetic energy is not equal to final kinetic. Then we define based on after the collision where the objects are moving in one direction or two directions. Based on line of impact, how they collide. You can say the first one dimensional collision, and second one you can say 2D collision. In basic way, if you want to understand, in case of one dimensional collision, if I say won't take collision. So if two objects are there, one is moving with u, one is moving with u before the collision and after collision. Before collision and after collision, velocity would be same, v1 and v2. Means it will be in the same direction. If I go for 2D collision, not necessary. For before the collision, not necessary their velocity are in the same direction. This is moving with v, moving with u. This is moving with u2. After the collision, before this one is also before collision, after. It may move in some other direction, given velocity. If velocity is involved in two directions, then it is two dimensional. Here we define one quantity that is called coefficient of restitution. This is the important concept. What we define, how we define it. It is defined as the velocity of separation by velocity of. Try to understand this. If I take the example of so here in this case, if I want to define the coefficient of restitution, what we can write, E will be V2 minus V1. This is how we define the coefficient of velocity of separation by velocity of. Let's do a problem based on collision. See, they have given a block of mass 1.2 kg is moving with a speed of 20 centimeter per second. Collide head on with a block at rest. The coefficient of restitution is 3 by 5. Find the loss of kinetic energy. So whenever the problems related to collision are there, the first step you're supposed to do, conserve the momentum. So there is a block of 1.2 kg. It was moving in this direction with a speed of 20 centimeters. Similar block is there. This one also mass 1.2 kg, but this was at rest. After the collision, they can move with some velocity, v1 and v2. So they are saying that due to this collision, how much kinetic energy we have lost. That they're asking. So what I can write, first thing, initial momentum should be equal to final momentum. So 1.2 into 0.2 plus other one was at rest, 0. 1.2 into V1 plus 1.2 into V2. So we can write here V1 plus V2 will become 0.2. This is equation. Now I need one more equation because two unknowns are there. So we can write coefficient of restitution. This we write what? V2 minus V1 by U1 minus U2. So V2 minus V1, coefficient of restitution we have given 3 by 5 into U1 minus U2. So U1 minus U2 will become 0. So V2 minus V1, this will become 0.1. If we add 1 and 2, 1 plus 2, what we can write? 2V2 will become 0.3. So V2 is equal to 0.16. If I want to calculate V1, so V1 we can write as any one of the equations. If I write from 1, V1 will become 0.2 minus V1, so minus V2, so 0.16. If I want to find here what is the loss in kinetic energy, what I can write delta K, half m1 u1 delta K. If you want to write, it will be final minus. So half m1 v1 square plus half into v2 square minus half m1 minus half. So half into mass is how much? 1.2. So 1.2 v1 plus v2 square. So 0.16 square plus 0.04 square minus u2 was 0. This was how much? It was moving at the speed of 20 meters. 0.2. That will whatever value. Here I will get negative. Negative means what? The energy is. So this is how we'll approach the problem related to the collision. The first step we have to conserve the momentum. In the next step, you can use the equation related to kinetic energy or coefficient. Take one more problem to clear the idea how to approach the problem. So we have given a block of mass m is moving at the velocity v, collide head-on with another block of mass 2m. If the coefficient of restitution is 1 by 2, they're asking find the velocity of the block. See then, we have given again the first step. What we are supposed to do? We are supposed to conserve the momentum. So initial momentum is equals to final momentum mv. This will be given as how much? Mv plus the other one is at rest 2m into 0 plus m into v1 plus 2m into v2. So v1 plus 2v2. This will come v. This is our equation. Second equation, what we can write? Coefficient of restitution we have given. So what we write? E equals to E we write v2 minus v1 by u1 minus u2. So v2 minus v1. U1 what we have given? It is moving the v1 and E is 1 by 2. V by 2. If I do from 1 plus 2, what we can write? We can write 3v2 equals to 3v by 2. So v2 is equals to how much? V by 2. V2 is v by 2. So v1 I can write as how much? 0. So they're asking what? They're asking find the velocity of the blocks after the collision. One is 0, one is v2. This is how we are going to approach the problem related to the collision. If we take one more problem, Let's take this. We have gained a ball of mass m moving the velocity v makes a hidden collision with identical laws. The kinetic energy of the ball after the collision is three-fourths of the original. Find the coefficient of restitution. See here the problem is different. In the last two questions, we have given coefficient of restitution. Here they're asking to calculate the coefficient. So again, same idea. First, conserve the momentum. Two balls are there. One is moving the velocity, other one is at rest. Suppose after the collision, this one is moving the v1 and this one is moving the v2. So initial momentum will be equals to final momentum. So mv equals to m into v1 plus m into v2. So what I can write? v1 plus v2 is equals to v. This is equation one. Second equation, what we can write? Suppose coefficient of restitution is e. So e I can write as v2 minus v1 by u1 minus u2. So I can write v2 minus v1. u1 is v, u2 is 0. E into v. This will become equation. If I add both these equations, so from 1 plus 2, I'll get v2 is equal to 1 plus e into v by 2. And v1 is equal to 1 minus e into v by 2. Now, I know v1, v2, I can calculate the change in kinetic energy. They are given about the kinetic energy of the ball after the collision is 3 by 4. It is original. So kinetic energy of ball will become 3 by 4 of the initial kinetic energy. So final kinetic energy I can write as half mv2 is half mv1 is equals to 3 by 4 half mv half m v2 what I can write 1 plus e into v square by 4 1 minus e square into v square by 4 3 by 4 into v square v square v square v square 4. So 1 plus e square plus 2e 1 plus e square minus 2e. So 2e square equals to 1. E will get 1 by 2. This is how we approach these problems. Again, I have done the same thing. What I did, I have conserved the momentum, then use the concept of coefficient of restitution. And once I know the coefficient, use this concept, I have two unknowns. I solve this equation. We have given the last statement as the final kinetic energy, 3 by 4 of the initial. I use that, and we have. So this was the discussion regarding the conservation of momentum topic. So next class will go for rotation. Done.